Thank you, and ladies and gentlemen. I'm going to make a presentation, and most of the work has been carried out by my student, Tomoko Teramoto. She is, hopefully, she will try to submit the thesis very soon. But I would like to introduce the background. It's a south basin of the Lake Biwa. Who visited Lake Biwa is well known. It is a very, very eutrophic clay basin. And when we did my PhD study, it was completely covered by the cyanobacterial bloom. However, due to the reduction of the nutrients, especially from the 2005 and 2010, and then from the regime shift, from harmful cyanobacterial bloom into the massive bloom of aquatic plants such as Egeria densa. It's a kind of a very popular macrophyte. And then that will cause significant difficulty rates when you make a kind of assumption. This is just showing how we will analyze the satellite image into the concentration. This is a picture from the NASA. We use radiance to reflectance, and this is very conventional and well-known technology that we are using. And also, we have, as a model, we use a satellite image and convert it as a three-dimensional shape. This has been carried out by Dr. Fujio Nakano. And then this is a normal image of the Landsat before and after the atmospheric correction in 1984. The problem is not always the lake surface is visible, and when it's visible, you have to have a ground truth data. And then this is 1989 and 1994. Obviously, some of the cloud is here. And for example, this is one of the results that we have estimated at aquatic plant using the method. But that should be implemented a little bit later. Now, this is also the projected chlorophyll concentration by the model. But I will show that some of the difficulties. Some points here are very well recognized, but for the north basin, when the chlorophyll concentration is very low, the prediction is somehow different. So we have to make a kind of adjustment for that. So for the validation, we use the Lake Biwa Environmental Research Institute sampling regular monitoring data. And we use, first of all, for the chlorophyll estimation and the regression analysis by the logarithmic and multiple analysis and multiple regression analysis, right? And this is, for example, the result, one of the results that didn't show up a very good outcome. Then we have tried and trying to use multiple analysis that improve significantly. The issue is there are several bands, of course, the visible ray and infrared band. But of course, the chlorophyll concentration has a particular range, but not always correlated the expected range. So we have to find out the way to correlate the band, which theoretically doesn't have a relationship, but in order to increase accuracy. And this is another result of the multiple analysis. So this is one of the outcome that we are trying to show you today. Because of the time constraint, I am just introducing one of the findings that we have done. There are several massive bloom of algae, not only the algae, it's an aquatic plant. So there are regular monitoring in the Lake Biwa and obtained how much density of those macrophytes. And we are trying to extract these points, the impact of the macrophyte, from the assumption without considering this impact. The first impact estimation, first estimation without considering that impact always overestimates the presence of the Chlorophyll-a concentration than the real concentration. But knowing the characteristics wavelengths that macrophyte, its aquatic plant, produce, then we can effectively eliminate those effects that can increase the rate of accuracy. Of course, this is the green one is improved assumption by the real ground truth data. And for those points, for example, here, it's improved the accuracy than the normal one. For example, this point is 2. And this point improved, but still there are a lot of discrepancy between the real value and observed value. This case, of course, the assumption is improved, but still there are huge gaps. So this is actually because of the too low concentration of the real Chlorophyll-a. Because in the 90 and 2010, the initial years of 2000, there are Chlorophyll-a concentration at the summertime is at least 20 to 30. And then occasionally it reached until 70 to 80. And if you concentrate it like phycocyanin, then that value increase. However, recently we cannot find those algae bloom. Then we have to think about minimizing the observed data and compare effectively to reduce these effects. So I will skip most of the presentation, but our aim is to integrate the modeling and satellite image and field observation to make an effective assumption. And also what I introduced yesterday, and to make the database capable to capturing those satellite image in the same field. For example, this they have like a lake surface shape that could effectively remove or just capture the necessary unit. So the conclusion is that through our study, we could effectively remove the impact of aquatic plant. But of course, we should go further, and we are trying to integrate those modeling approach. Thank you very much.
Thank you. One short comment or question, please.
I wonder how important is resuspension?
In general, the sediment resuspension doesn't affect too much because clearly you can distinguish like the Chlorophyll-a or green color and from the sediment. But sometimes, of course, there are different kinds of the sediment, and that might give a clear difficulty. But probably in such case, if you take a look at RGB image, and then you can clearly distinguish the green one and also the sediment-based one. But I think this is, of course, a big problem that we have.
Sorry, I will just see that the model was estimating the observed values. What could be the reason for that?
What?
There was an overestimation of the results. If you just go to the slides where you are showing.
Yeah, actually, what I'm showing is you have ground truth data, right? We are trying to assume those data from the satellite image, and there are sometimes the overestimation by using the satellite image occurred because of the presence of the macrophyte. So we have to eliminate those effects to predict the real.
And were you doing any uncertainty analysis from the model?
Yeah, we have done, but I'm not showing today. But of course, there are a lot because we have to think about the differences of the water color, and several factors should be considered. And each lake has significant characteristics, and that should be considered too.
Thank you very much.
Thank you very much.